In this video, we're going to look at how to use Bob Martin's clean architecture to build a microservice in Node.js with Express and MongoDB. And as an added bonus, we're going to sprinkle in a little artificial intelligence. Hi, I'm Bill Sarur from Dev Mastery, and you're watching Mastery Monday, a weekly show that helps you write better code and advance your career. Don't forget to subscribe and hit the notification bell so you never miss an episode. So this is the clean architecture. It's an architecture model that was developed by Uncle Bob Martin, who's a pretty famous programmer and author who you've probably heard of. I recently used this architecture model in order to develop a microservice that's going to handle managing comments for my upcoming website. In this video, I'm going to take you through the code for that microservice, and I'm going to show you exactly how I applied this architecture style to that code. In over 20 years of developing applications, I have found that this is by far the best style of architecture to use if you're trying to build code that's meant to stand the test of time. When you use this architecture, you end up with an application that is very, very resilient in the face of change. So as things change in the world around you, your code can survive and adapt and change with it. All right, let me show you the microservice so you can see what I'm talking about. We're using an app called Postman to send HTTP requests to our microservice and see the response. So we've got the microservice running on localhost, and we can post a brand new comment. So for a comment, we need an author, and in this case, it'll be Wayne. We need some text for our comment, so Wayne will say party time. And of course, we need a reference to the post. So here we've got Wayne saying party time on this post. And if we send this, we get back a posted object that contains an ID, tells us the author, when it was created. There's a hash to uniquely identify the comment. Tells us when it was modified. Of course, it was modified at the same time as it was created because it's a brand new comment. There's the post ID that references the post that we're commenting on. We can see the comment's already been published, so published is set to true. And we've got some information about where the comment came from. So we've got a source with an IP and a browser. In this case, obviously, it's coming from Postman. And then finally, the text of our comment, which is party time. We can also reply to comments. So if we grab the ID of this comment, we can use that as a reply to ID. And now we can have Garth say, excellent. And we'll send that. And there you go, same idea, except now we've got a reply to ID. So behind the scenes, all of this is going into a database. So we've got MongoDB running here, and if I refresh this, there's our two comments, Wayne and Garth. And you'll notice that each comment is its own record, so they're not nested within each other. However, if I go back to my Postman, and we grab the post ID, we can use that to get all of the comments for this post ID. And you'll notice that the responses come back nested. So we've got Wayne saying party time, and then within the Wayne record, we've got a replies array, and that's going to be Garth saying excellent, and no replies to that. So there's a bit of logic running behind the scenes in our code to make this happen. So as you can imagine, we can update or edit any comment that we want. So by grabbing the ID of Garth's comment, we can change and have him say party on Wayne, so we'll send that. And there's the edited comment. So you can see the modified on date has changed. The created on is the same. And Garth is now saying party on Wayne. So what happens if we want to delete this parent comment? So here's a comment that's got a reply to it. If we delete it, what happens to the reply? So let's check it out. We'll grab the ID here. Head over to delete. Pass in the ID, and you see we get this deleted object that comes back. It tells us one comment was deleted, but it has soft delete set to true, and we've got a message that says the comment has replies, so it was soft deleted. So if we go back to get and run that, you can see now the author is deleted, and the text says this comment has been deleted. So that preserves our little hierarchy, our tree here. And if we grab this ID, try to delete that, you can see now the deleted count is 2, soft delete is set to false, and it says comment and parent deleted. So if we go back to our get, see nothing. So both comments were now deleted because there was nothing left in the comment thread. So that's all logic running behind the scenes. And it's important to focus on what the business logic is so that when I go over the architecture and the code, you understand where the benefits are. So a lot of these tutorials tend to focus on the tools, and there isn't really much business logic at all. They're just grabbing whatever comes over the wire and jamming it into the database. Here, we're actually applying some rules and some logic to the data, not just blindly sticking it in the database. So there is one more small trick that we have up our sleeve. So let's say, for example, that we wanted to have a new comment from Garth that is slightly inappropriate. So we'll have Garth say, "Yeah, when monkeys fly out of my butt." And so if we send that, you can notice that our published comes back as false this time. So the comment did not get automatically published. And the way that works is behind the scenes, I'm actually using a service from Microsoft Azure called Content Moderator. And so, if I was talking to a client, I would say, I've turbocharged our microservice by using a cloud-based AI. Between you and I, it's an API that I'm calling from Microsoft that tells me whether or not the contents of my comment may be inappropriate. And then based on that, I set the published to false so that the comment doesn't automatically get published with something inappropriate in it. Gives me a chance to go in and review it. And by the way, this is how I think for the most part, most of us are going to end up interacting with and using artificial intelligence. There's going to be APIs and libraries out there that do all of the real AI kind of stuff, and we're just going to consume those libraries or APIs. I'm also behind the scenes using something called Akismet, and Akismet is spam detection service. So that's going to make sure that if somebody somebody purposely tries to put spam on my site, it's going to get caught by Akismet, and again, I won't publish it. And so all of these features that I've just shown you are all built using the clean architecture from Bob Martin. So let's jump into the clean architecture. I can show you what that's all about, and then we'll hop through the code, and I can show you how I've applied the clean architecture to the code so that we end up with this result. All right, so this is Bob Martin's clean architecture, and you'll notice it's made up of 4 concentric circles. So in the center, we have a circle labeled entities. So entities are the primary concepts of your business. So let's say you're building an application for an insurance company, you might have an entity like a claim. Or if you're building an entity for some company that sells products, you'll have entities like customer, order, product. These are all what we call entities. If you're building a social media application, you might have an entity like a post, for example, or a comment. Next, we have what are called use cases. So use cases are interactions between entities. So if we're in our insurance company example, you can say that you'd have a use case like filing a claim. Or for our retailer example, you might have a use case like customer places an order. Likewise, in a social media setting, you might have user posts a tweet. Next, we have our adapters in green. And so adapters are there to isolate our various use cases from the tools that we use. So from the frameworks and drivers that we may be using to deliver our application. And that's the final circle. So that final circle is all about these frameworks and drivers that we all use to build our applications. And so in the case of my microservice, I'm using Express as a framework, and I'm using the MongoDB driver for Node.js as a driver. The next thing you'll notice is there are these arrows pointing from the outermost circle down into the innermost circle, and they go only in one direction. And so those arrows signify the flow of dependency. They say that an outer circle can depend on an inner circle, but an inner circle cannot depend on an outer circle. And that rule is the magic that makes this whole architecture hang together and work and deliver all kinds of value. So if you think about it, if the flow of dependencies goes from the outside in, that means changes are going to ripple from the inside out, right? So if something changes in a framework or a driver, since there's nothing depending on that framework or driver, the change is isolated to that one circle. On the other hand, if something changes in an entity, well, the use cases depend on our entities, and the adapters depend on our use cases, and the frameworks depend on our adapters, and so that change has the potential of affecting every layer. And so what we do is we put the things that are most likely to change over time on the outside, and the things that are less likely to change over time on the inside. And that's what makes this architecture so resilient in the face of change. Of course, you might have noticed there's a problem with all this. So if you've got a use case like place order, for example, customer places order, how is that going to work without the use case being able to access the database? Because chances are the order is going to have to be saved into a database. And so you would think that the use case would have to call our adapter and talk to our database, which would invert the flow of dependency. Well, that's what this little sub-diagram in the bottom right is all about. So when we zoom in, we see on the left-hand side, we've got a controller and a presenter. Both of these are examples of adapters. And on the right-hand side, we've got our use case that has been split into 3 boxes. So in the center, we have the use case interactor. And so that's the logic that actually governs the use case. And then on the bottom, we've got an input port, and on the top, an output port. And you'll notice there's a tiny uppercase I in the corner. And so that tiny uppercase I stands for interface. That means that the use case input port is an interface that is satisfied by the controller. And the use case output port is going to be an interface that will be implemented or satisfied by the presenter. Now, if you've got a JavaScript background and you haven't done a lot of programming in other languages, you may not be used to this idea of capital I interface. Because in JavaScript, these kind of interfaces don't really exist. But the good news is, to do what Bob Martin is describing here, all you really need to be able to do is inject your dependencies rather than import them. And that's pretty straightforward to do in JavaScript, and I'll show you as we go through the code. So let's do that. Let's jump into the code and have a look. So here we are in GitHub, and I've put a link to this repo in the description so that you can follow along with me. And the first thing we're going to do is look for our entities. So we'll jump into the source folder. And then, since this code is all about comments, it's not surprising that our entity is going to be in a folder called comment inside of a module called comment.js. In here, the first thing you'll probably notice is that there are no import or require statements at the top of our code. So typically when you jump into a JavaScript module, the first thing you see is lots of require statements or import statements. But in this case, we're not importing anything and we're not requiring anything. And that's important because this is an entity. And if you'll remember from our diagram, entities are in the center. So entities have no dependencies. So if we were importing or requiring libraries or other code, then those would constitute direct dependencies, and we can't have that. So instead, what we do is dependency injection. So you'll see that what we export here is a function called build make comment, and that's going to receive all of our dependencies. So somewhere upstream, we've got some code that will call this function and inject all of the various dependencies that the function requires in order to do its work. And that has a number of advantages. The first advantage is testability. So now by injecting the dependencies, I can actually stub out any of these dependencies so that I can test this code independently of anything else. And I can make my stubs behave however I want so that I can test different behaviors and interactions. The other advantage is, as I'm building this code, I don't need all of the dependencies to be ready. I can just write simple little stubs that I can implement later and focus on the business logic for a comment. Finally, and most importantly, the advantage of doing this is that I can change the implementation details of my dependencies independently of this code. So what that means is I have a function here called sanitize, and it works to make sure that there's no invalid HTML or like script tags inside of my comment text. Now, I'm depending on a third-party library to do this work that's coming from NPM. But in the future, I could write my own sanitize function, or more likely, I can swap that library for another library that maybe does it better or that's better supported. And I wouldn't have to touch this code at all. And that's very, very valuable because that means that I'm not risking any of the business logic of my application in order to upgrade or change a tool that I use from a third party. So if we jump into the code here, we'll notice that ultimately we're returning a function called makeComment, which is a factory that can return us an instance of our comment entity. And we receive all of the properties that make up a comment. We put some sensible defaults in, and then the code just validates all of the inputs, making sure that it enforces all of the business rules for a comment. And you can see it's very easy to read. So a comment must have a valid ID. It must have an author. The author's name has to be longer than 2 characters. It must contain a post ID. The comment text must include at least 1 character of text. The comment must have a source. So the source is what we looked at earlier, where we saw the IP from which the comment was coming from in the browser. And then if there is a reply ID, it's got to be valid. And so this is a very nice way of being able to see at a glance what all the business rules are for a comment. And these are all enforced and handled by the comment entity. So a comment knows everything there is to know about what it means to be a valid comment. We have our sanitized text, which uses the sanitized library that I pointed out to you before, and this is coming as an injected dependency. Next, we make sure to validate that after we've sanitized the text, there is still some text left. For the source, we use a make source factory, and we consider source another entity of our application. It's a sub-entity of comment. And so this make source factory, similarly to the make comment factory that we're inside of now, knows everything there is to know about making a valid source. So in here, you would expect to have all the similar kind of validation for the various properties of a source. Next, we set a constant for what we're going to use to mark a comment as deleted. So this is the deleted text that will appear when we need to soft delete a comment. And then we specify a hash attribute of our comment, which will populate a little later. So finally, we return a frozen object that exposes a bunch of get methods. And what's valuable about this is that it indicates to the consumer of this code that they are only allowed to read these properties and they have no way of directly changing the properties. We do everything we can to make sure that there's absolutely no way to put this entity into an invalid state. So if something is going to break, it's going to break on entity creation, which means that we'll have a very fast and early signal that we've done something wrong in our code. And that makes things super easy to debug. A very, very common source of errors and problems in code is when you can have some code that puts an object or an entity into an invalid state, and then you don't realize that that entity is in an invalid state until you try to use it in some other code down the line. And then it becomes very difficult to trace the source of the bug. So you know that there's an error happening in your application because your object is in an invalid state, but you don't know how or where that object got to be in that invalid state. So here we make it impossible for code later down the line to put this object in an invalid state. So if you're going to put it in an invalid state, it'll happen on creation. And if it happens on creation, we'll throw an error and you'll know exactly where the source of the bug is. So moving on, if you do need to change, or if we do need to change some properties of our object, we can do that through functions. So for example, we have a function called markDeleted. And under the hood, that's changing the sanitized text and the author property of our comment entity. And so that's the only way to modify these properties. You can't just go comment.sanitizedText equals something else. So that preserves the integrity of our entity. Hopefully that makes sense. So if we jump back out to our parent folder, you'll see that we expose our comment via an index.js. And if we look at index.js, this is now where we bring in all of our third-party or internal dependencies and libraries. And so this index.js is responsible for building our make comment function. And then it's going to just export a valid version of the make comment that has all of the dependencies embedded in it. So again, like I said, this means that if we need to change some of these dependencies, if we need to use a different crypto library or a different sanitized library, for example, we can do so without having to interfere with the business logic of our comment entity. And you can see here, we're bringing in sanitized HTML from a third-party library, and then we're writing our own little sanitize function that does some configuration of this third-party library on behalf of our comment entity. So we've really now cleanly separated the business logic from the dependencies. So if we jump all the way back out to our source folder, we can now look at our use cases. So use cases describe all of the valid interactions within our application. And you can see just from looking at the folder listing, you can tell exactly what this application does. So you can add a comment, you can edit a comment, list the comments, remove a comment. There's something about handling moderation. So this gives you a very nice map and a very nice indication of all of the features and functionality of your application just at a glance, which is quite nice. So we can jump into the add comment use case and see what's going on there. So here you'll notice now there's one import, and that import is for our comment entity. So you'll remember from our diagram that use cases have a dependency on entities. So it's valid to import a concrete implementation of an entity into a use case. And then we use the same technique. So we have a make add comment factory function that's going to receive the dependencies of this use case. And these dependencies, the comments DB and the handle moderation, which we'll look at in a moment, these are adapters. So they come from the green layer. And based on that second diagram, even though we don't have interfaces, we're using dependency injection to make sure that we're not tightly coupled to our dependencies at design time. We only become tightly coupled to them at runtime. So our make add comment factory returns an add comment function that receives some data which constitutes comment info. And we use the comment info to make a comment entity. And so in here, this is where all of the business rules and knowledge and information about what makes a valid comment will come into play. And so if anything is invalid in this comment info, we'll find out right away here. Next, we check if the comment exists by going to the database and using the comments hash property to find any similar or identical comments. And if the comment exists, we just return the existing comment. So this makes sure that if a comment gets submitted twice, we don't add it to the database twice. We don't add any duplication. So that's a bit of business logic that belongs in the use case. So the use case is aware now of the interactions between the various parts of our system. Moving on, we have this notion of handling the moderation of a comment. And so that's a dependency that was injected here. That's a different use case that understands how to deal with comment moderation. So if the comment is inappropriate or if we need to do something to review the comment, that's all going to be handled in there. Finally, we grab the comment source and then we insert a comment record into our database. And notice what we're passing to our comments DB is just a plain object with plain properties. And those are all coming from our comment entity. So we know that all of this stuff has already been validated and is good, but we don't need the comments DB, which is an adapter to our database, to know or understand anything about the comment entity. It's just receiving a plain object. And that's another principle of the clean architecture. You need to pass information between layers in the format or structure that is most convenient for the layer to whom you're passing the information. Let's look at another use case. As you can imagine, edit comment would be pretty similar. Let's take a look at handle moderation and see what's going on here. So again, a factory function, and we're injecting two dependencies. So one dependency for some function called isQuestionable, and another dependency of a function called initiateReview. And again, because this is a use case, these dependencies that we're injecting, these are adapters that are interfacing with some framework or library or other system external to our use case. So our handle moderation use case basically checks to see whether or not the comment is questionable. So we get a comment entity in here and we ask the question, should this be moderated? And we do that through this isQuestionable function that was injected. If it turns out that a comment should be moderated, we call our initiateReview and we pass in the ID and the text of our comment. And then we make sure that the comment is not automatically published. So that's that functionality I showed you earlier where I tried to publish a comment that had some rude text in it and you saw that it came back as published false. That's what's happening here. We're calling unpublish on this now moderated version of our comment entity. So moving back into our use cases, we can take a look at remove comment. And so again in here, we're bringing in our comment entity. We have a factory function where we can inject our comments DB. And then in here, we've got all of our business rules related to removing a comment. And so the one that's probably interesting is this soft delete. So here we're saying if a comment has replies, we want to soft delete it. And if we go and look at this soft delete function, which is over here, what we can see is that we go and we make a comment entity out of the comment info that we've retrieved. And then we call mark deleted against our comment entity. And so the interesting part about this is this code here has no idea what the implementation of mark deleted is. It doesn't need to know or understand how a comment gets to be marked deleted. That's left up to the comment entity. And so here we have this nice separation of concerns where the business logic that's relative to the comment itself is handled by the comment entity, and then the business logic that's relative to the use case is handled here inside of the use case. And so down the line, if we change what it means for a comment to be deleted, we can go into our comment entity and change the code or the implementation in there, and that would just all work. So this code would not have to change. And so we've created this nice separation where we can change things independently of each other. Okay, so jumping back into our use cases now, we expose all of these use cases via an index.js. And so this index.js brings in all of our factories, and it also brings in our dependencies. It's going to create our handle moderation use case. And you'll notice here, this is an example of a stub. So I haven't written or completed the initiate review functionality yet. Behind the scenes, this is probably going to kick off a process that will notify me of the fact that I need to go in and review a comment because for some reason it's questionable. But I can write all of my logic and all of my code without having fully implemented this initiate review functionality because it's just being injected in. So here, this is just a stub. And that's one of the advantages I was talking about earlier. Then as you can imagine, we make our add comment use case, our edit comment use case, list comments, remove comments, again, injecting all of our dependencies. And what this ultimately returns is an object that contains all of our use cases. So a single object that will contain all of our use cases. And then for convenience, I'm also exporting all of the individual use cases so that we can pull out one at a time if we need to. Hopping back to our source folder, we can jump into the data access folder and take a look at comments.db. And comments.db is just an object that exposes a bunch of database interactions. So this thing protects us from a direct dependency on our database from the rest of our code. So the rest of our code doesn't know how to issue a MongoDB query to find all comments. That's handled in here. This is the only place that understands and knows how to interact with the database. And even then, we're injecting our database connection code so that in the future, if we need to connect to a different Mongo compatible database, we can do so without having to touch this code. Of course, if we move away from a MongoDB style API, then this code would be affected. But that's okay because this code is completely isolated from our use cases and our entities, so from our main business logic. This code is only concerned with how to write the code to retrieve and put the information in and out of the database as required. And so as you can imagine, our index.js is going to set up our connection and make our comments.db adapter. And the nice thing about this is when we go, if we go out here and we look at our tests, so this is our spec file, we can actually bring in a different makeDB function. So for testing purposes, we're using an in-memory database rather than trying to use the instance of a running MongoDB database on our local system. And that's really helpful. So we can do all kinds of faster parallel testing, etc. So let's jump back to our source folder. And now in here, we can look at controllers. So just like data access, controllers is another example of a type of interface adapter. So that's that green layer inside of our clean architecture, that green circle that is the second from the outermost circle. And in here, we can take a look at post comment, for example. And so now you can see, similarly, we've got this factory function, and now we're injecting our use case. So this injects the add comment use case into a factory function that's going to return us a post comment function. And post comment is going to expect an HTTP request, and then it's going to extract data from the HTTP request and then pass that data to our add comment use case. Then it's going to return an HTTP response like object. And so here you can see for the first time, we're dealing with actual constructs and parameters of HTTP type interaction. And this keeps that cleanly separated from the use case. So the use case has no idea what context it's running in, whether it's inside of an HTTP application or inside of a desktop application or on the front end or on the back end. It doesn't care. It's here now where we deal with the HTTP concerns. But similarly, in here, inside of this controller, we don't really care about the implementation or the details of add comment. None of the business rules for adding a comment exist here. Here we're only concerned with the rules around HTTP interaction, request response. And again, going back out, as you'd expect, we've got delete, we've got get, we've got patch, and then of course we've got our index.js, and our index.js, in the same way that we've exposed our other functionality or the other layers, we import our dependencies, inject our dependencies using our factories, and then export an object that exposes all of our various controller methods. And again, for convenience sake, we export them individually as well. So moving back to our source folder, so we can now look at the entry point to our entire microservice, which is this index.js file right in the source folder. So if we go in here, finally we get to the point where we're using Express, so the Express.js framework to communicate over HTTP. And now in here we import all of our controllers that we just saw, so delete, get, post, patch, etc. And then we pass those controllers into Express's various methods. So this is Express.js, if you're familiar with it. You've got a post, a delete, a patch, and then you pass in a route. And then you give it a function to handle requests to that route. And so our function that's handling that is our controller. And then we've got one extra little bit of indirection here. We're using this make callback function, which you can see is imported up here from Express callback. And all make callback is, this is just an adapter that takes our controllers and turns them into an Express.js style callback. And so Express.js expects a function here that receives a rec and a res object. And so that's what this make callback does. And so we can actually go look at that. So if we jump out to source, we can take a look at Express callback. And we see here, so it's going to receive one of our controllers, and then it's going to return a function that takes a rec and a res. It's going to map the rec object to our generic HTTP request object, pass that along to our controller. After our controller has done its work, it's going to map an HTTP response. So that's what's returned from our controller. It's going to map that to a res object, and then use the res object to set the status and send the response. So going back, we see that in here, we see that Express is actually depending on our adapters rather than having our code depend on Express. And that's the last circle in our clean architecture. And we've managed to preserve the flow of dependency so that the frameworks are depending on our adapters, which are depending on our use cases, which are depending on our entities. Hopefully you found this helpful and useful, and I'd love to see you back on this channel again. So don't forget to subscribe and hit the notification bell. And you can also check out my website at devmastery.com, where you can sign up for my newsletter and be kept up to date on all the new videos, as well as articles and other content relevant to developers like you. So take care, and we'll see you next time.